Okay, now we will start with scientific notation. Okay, which of these is bigger, the federal debt or the wealth of Bill Gates? Now, I know it's not that hard to see, but I just have a point here. They're obviously in different fonts for a reason, but the federal debt's bigger than the wealth of Bill Gates, but maybe at first glance you thought maybe I better count digits. So now let me just ask you a different question. If you're comparing these numbers, which way is easier to look at them? This way right here, or we put the commas in. Remember the commas that you learned how to put in elementary school? Well, that makes it a lot easier because all of a sudden I can see my thousands and millions and billions and trillions. So we can see that the federal debt is in trillions, the wealth of Bill Gates is in billions. It just is easier to kind of get the comparison once we can see the place values. So which is easier, comparing them here or making it even more explicit? Let's look at it right there. Well, obviously, we know a trillion is more than a billion, so even though 44 is more than 11, the trillion trumps billion. I look at the order of magnitude before I look at the specific value. Okay, now here is one last way to look at these numbers. This is one that you may or may not have seen. It's not used as often, but is actually even more useful than talking about trillions and billions, and that is scientific notation. So let's look at this one right here. The federal debt would be 1.104 times 10 to the 13th. So that means that it's essentially 1 with 13 zeros. The wealth of Bill Gates is 4.478 times 10 to the 10th. So it's essentially 4 with 10 zeros. Well, a number with 13 zeros is a lot bigger than a number with 10 zeros, so obviously the federal debt is bigger than the wealth of Bill Gates. One thing to note, 100 is 10 squared. That one we know. 1,000 is 10 cubed. 100,000 is 10 to the 5th. So if I have 10 to the 13th, that is 1 with 13 zeros. Okay, so let's write numbers in different ways. If we had 345, we could call that 3.45 times 100, or 100 is 10 squared. 3.45 times 10 squared. The easiest way to think of those is I want it to be 3.45 because I want one non-zero digit in front of the decimal. And to do that, I need to move the decimal point twice. Since I move it twice, I get the 10 to the second. Again, if I had 34,500, I still want 3.45. I want that decimal between the 3 and the 4. But how many times do I need to move that decimal point now? Well, I've got to move it before the 0, before the 0, before the 5, before the 4, so I have to move it 4 times. So it's 3.45 times 10 to the 4th. Okay, if I had 27,314,000, I want the decimal point between the 2 and the 7. So I'd have to move it in front of the first group of zeros, that moves it 3 times. In front of the 314, that moves it 6 times, and then move it one more time, so I'm moving the decimal point 7 times. So it's 2.7314 times 10 to the 7th. Scientific notation is very useful for comparing or working with very large or very small numbers. So let's just look at these quickly. Which of these numbers is the biggest? Pause the video and take a look at them. We've got 123, but then that only has an exponent of 23. I've got 34, but that has a big exponent. And then the 26, but that only has a 1. I thought this was going to help me compare these numbers. Well, let's write them a little bit differently. Let's keep the 1.2 times 10 to the 26th the same. But instead of 34.5, let me write it as 3.45 times 10 to the 26th. It's exactly the same thing. I moved the decimal point 1 time, and so I changed the exponent by 1. I made the number on the left a little bit smaller, so I make my exponent a little bit bigger. For 123.45, I moved the decimal point 2 times, so I make my exponent 2 things bigger on the magnitude. Now, if I look at these, I know my 10 to the 25th is out of the running for being the biggest because the other guys have more zeros. So now I'm just comparing the 3.45 times 10 to the 26th and the 1.2 times 10 to the 26th. So the middle number actually is the biggest. It's not usually the one that people choose when they're green, but once they're written in that purple form, that makes it a lot easier. So scientific notation, those green numbers, well, the first two green numbers are not in scientific notation. They might look like they are, but they're not. Scientific notation only has one non-zero digit to the left of the decimal point. That's critical that you get that part. And we'll talk about it quite a bit later in the lecture too. So let's convert numbers to scientific notation. Let's say the circumference of the Earth is that many kilometers. Look at how many times the decimal point has to move. Well, it has to move 1, 2, 3, 4 times. So it's 4.007542 times 10 to the fourth. One thing to keep in mind, if you're making your number smaller, your exponent's getting bigger. So an iPad Classic holds 30,000 songs. That's 3.0 times 10 to the fourth. I moved my decimal point again 4 times. Now this time, am I making my number larger or smaller? Okay, now when I move that decimal point, I'm moving it to the right. I'm making my number bigger. So I've got to compensate by making my magnitude, my 10 to the power, smaller. So I move my decimal point 5 times, but it's 10 to the minus 5. So if you have a 10 to the positive exponent, that's a big number. A 10 to a minus exponent is a small number. So what would be the probability of winning the lottery? Do that one on your own. Okay, good. The decimal point needs to go in between those two fives. I want one non-zero digit to the left of the decimal point. So I had to move it 8 times. I made the number bigger, so I had to make my exponent smaller. Okay, so positive exponents mean big numbers. Negative exponents mean small numbers. Okay, let's go the other direction. The Earth's orbit is that many meters. Convert it to just a standard number. So I take my decimal point and move it 11 times. But how do I move it 11 times? There's only 2 decimal points. Okay, I'd move it past the 4, past the 9, and then I'd add on 9 zeros. Very good. So I move it 11 times. Once for the 4, once for the 9, and then I've got to get the other 9 of them in zeros. The weight of a flea is 6.6 times 10 to the negative 4. So that negative 4 tells me I'm going to move my decimal point to the left or the right? To the left, good. I move it to the left 4 times, so I have to put in zeros to compensate, so I have 0.00066 pounds. The amount of your life that today's class took. Now, are you going to move that decimal to the left or the right? Okay, it'll move to the left because a negative exponent means a small number. I'm making the number smaller. So I'd have 0.00000207. The Earth's population, would I take that exponent to the left or the right? Okay, I'm going to take it to the right and make the number bigger. So I move it past the 763, and then I add on 6 more zeros. So that is just converting numbers back and forth. We will do other things with our scientific notation in the next video.